Alright, welcome to the discussion video for 2.6, which is combining functions. There were a few problems asked to cover, so we'll just jump into these. Let's start with number 3. So we have two functions. F of x is x minus 9, and g of x is x squared. And we are asked to find the domain. Right? So the domain is all of the values that I can, we're asked to find the domain of f over g, right? There we go. F over g of x, right? Which is simply to say f of x divided by g of x, right? So f of x, which is x minus 9, divided by g of x, which is x squared, right? Now, I've also been asked to do a separate video on domain, so we're going to talk about that in depth in another video. If you want to skip to that before you jump into this, maybe look down 2 videos down from this where you clicked. There's going to be a domain video that pops up. But when you do that, come back. The domain here is essentially all of the x values that I can plug into here and get a valid answer out. But if I have one function being divided by, say, g of x can't be 0, otherwise my denominator is 0, and then I have an issue, right? So g of x cannot be 0, that is to say my denominator, x squared, can't be 0. Anything else goes, right? F of x is just x minus 9, it's a polynomial. All real numbers will work in here. The only issue I have is when I try to divide by something, I can't have that something be 0, right? So x squared can't be 0, but the only way x squared will be 0 is if x is 0, and therefore my domain is x cannot be 0. It could be anything else, right? So the answer is in interval notation, so it would be simply negative infinity to 0, excluding it with a parenthesis there, and then union with 0 to infinity. It's basically everything except we've removed that 0. Right? Later on you might, when you get to writing these, it gets a little bit obnoxious. You might also see this has nothing to do with, you don't need to know this, but you might also see this as all real numbers without the point 0, which is a little bit quicker to write. Right? But again, you don't need to know that. It's nifty, but who cares? All right. Let's move on to number 5. Number 5 says, I have two functions again. F of x is the radical of 2 minus x squared, and then I have g of x is radical of 5 plus x. Okay. So we can talk about domain issues right from the get-go before we even look at the problem, right? There is a domain issue with f of x. This 2 minus x squared has to be greater than or equal to 0 because it's under a square root. And that's what gives us our domain here, right? Which is to say if I add x squared to both sides here, right, then I've got this 2 is greater than or equal to x squared. Right? That means when you square your number, you can't go further away from 0 than 2, right? Which is to say, then we're kind of stuck between the square root of 2 and the negative square root of 2. All of these numbers, when you square them, are going to be less than 2, right? So the f of x has a domain, and that is simply the numbers between negative root 2 and positive root 2. And I can include the endpoints. So that's my domain of f of x, right? Before I've even done anything, if I include f of x in some composite function, I have to be limited by this domain right from the get-go, right? Now let's look at g of x. I'm going to erase a little bit of this because I'm going to definitely run out of room. Okay. G of x has a domain issue as well. That is to say 5 plus x has to be greater than or equal to 0, once again because it's under the square root. And therefore if I subtract 5, I get x is greater than or equal to negative 5, right? Okay. So that is to say g of x has a domain. I'm going to erase this. It's greater than or equal to negative 5. That is to say it is negative 5 to infinity, right? Any of those numbers will work. So I'm limited by these two domains depending on what I do, right? There may be more domain issues that pop up. The question, though, is find the domain of f plus g of x. Well, f plus g of x is just the two things added together. So that is the square root of 2 minus x squared plus the square root of 5 plus x. Now I didn't divide anything, so there's no zeros in the denominators that I have to worry about. I didn't take anything inside another square root, right? So there's no real other domain issues that pop up from just adding these two together. I just have to simplify this and find the intersection here, right? Because my domain has to satisfy both, because both of them appear here, right? So the domain is whatever these two are put together. So let me get rid of this, because it doesn't ask you what this is. It might ask you what this is in 4 or 6. It does. It asks you, that's what 4 is. There's number 4. But the domain is the intersection of this. And so if I take a look at what's happening, draw this line back here. I have negative root 2 to root 2, right? These guys, this is my domain in picture form of f of x, right? And g of x is negative 5, which is to the left here, off to infinity. But again, I'm looking for the intersection of these two. And the intersection, well, all of these values in the red line are here on the green line. And that's my intersection, is whatever's here on the red line, right? So all of these values over here, they don't matter. All of these values between negative root 2 and positive root 2, they show up. We're good here, but these guys are out because they're not in the intersection. And therefore, the domain of the sum is the same as the domain of f of x, because that is the intersection. Good. All right, let's take a look at number 8. Eight says... it's the same two, well, I erased it. I think it's the same two, but number 8, I have f of x is the square root of 2 minus x squared. And then g of x is 5 plus x. I think that's the same two functions, I don't know. But we're trying to find f g of x. And this is just the product of f and g, right? This is the same thing as just taking f of x and multiplying it by g of x. Can I make that a g? That's a terrible g. G of x, right? So that is to say I have the square root of 2 minus x squared multiplied by the square root of 5 plus x. And that's my answer, except that they've simplified, well, simplify is a relative term. They've multiplied these together, because the square root of one thing multiplied by the square root of the other thing is then the one thing, so 2 minus x squared gets multiplied by 5 plus x. You can do that under one square root now, and then you just FOIL these together. So I've got 5 times 2 is 10, 5 times minus x squared is minus 5x squared, and then x times 2 is 2x, x times minus x squared is negative x to the third, and that's all still under a square root. And then the answer that I'm looking at here is this, but then written in descending order. So negative x to the third plus 2x minus 5x, or sorry, negative x to the third minus 5x squared plus 2x and then plus 10. And that answer you'll find there. Maybe I should not erase this, because let's look at number 9, which is the same two functions. Equals 2 minus x squared. Alright, number 9 says the same two functions, we want to find the domain, right? And so I'm going to erase all this. It's nifty that we have this, but it's not terribly important. The domain is still the intersection of these things, right? 2 minus x squared has to be a positive or zero number. 5 plus x has to be a positive or zero number. So in fact, actually, I'm not going to write any of this because it's the exact same thought process when we did the sum f plus g. It's simply the intersection of those two domains, right? And therefore it would be between the negative root 2 up to the positive root 2, just like it was on problem 5, I think, is what it was. Alright, let's take a look at number 11, which is the same. Now though, for 11, they've asked us to find the domain of f over g of x. Okay. So there's two things going on. I'm using f, I'm using g, and therefore the domain of any composition of f and g, we've already discussed this in problem, I don't remember, I think it was 5. In problem, whatever I just did, 9. You would think I could remember two numbers for 5 seconds, but I can't. But those last two problems, the domains that we found that included f and g, had the domain of simply f, which was negative root 2 to root 2, right? This problem, though, has one more thing that I have to worry about, and that is g. And when g is in the denominator, all of a sudden g can't be 0, right? And so that is to say, I have to also be concerned with 5 plus x can't be 0, right? But if I subtract 5 here, x can't be negative 5, but it's already not, because my domain is already limited to numbers that don't include negative 5 anyway. So this, while I do have to satisfy it, I already do, so I don't have to worry about it. And so my domain is the same, it's still negative root 2 to root 2. Hopefully that clears those up. Hopefully it clears up. There's some questions on domain. Again, I'll do another video kind of doing the basics. So hopefully you stopped and watched that first. But let's move on. Let's look at number 20. Which hopefully has new sets of functions. Alright, so 20 says find the domain of the function square root of x plus the square root of 6 minus x. So really we're just talking about the sum of two functions here. I have some function, call it f of x if you want, that's just the square root of x. Some function, call it g of x if you want, that's the square root of 6 minus x. I really just have to satisfy whatever's under this one Square root has to be greater than or equal to 0. So I'm limited to x is greater than or equal to 0. And then I also have to satisfy 6 minus x has to be greater than or equal to 0. If I add let's subtract my 6 over. A lot of us like to see the x on the left-hand side. If I divide by -1 here, remember to flip your inequality. Right? So this is an and, it's an intersection thing. I have to satisfy both of these. That's an intersection of x is greater than 0, greater than or equal to 0, and x is less than or equal to 6. So that's just the numbers between 0 and 6, and that's it. 0, 6, you can include them because of the inclusive inequalities here, and so my domain is simply that, 0 to 6, brackets. All right, let's take a look at the last one that was asked was number 25. Which says, I have two functions, f of x is 5x minus 4. And I have a function g of x is 2 minus x squared. To evaluate the following, write down your answers in descending order, blah, 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 f composed of g. All right, this symbol here, the open circle, means that this f eats up the g, and so you get, essentially, you can write it this way, f of, instead of an x, you get g of x plugged into f, right? So that is to say, I'm going to take this g of x, which is 2 minus x squared, and cram it in place of this x here. So I get 5 multiplied by, instead of x, this expression 2 minus x squared, and then minus 4. So it's the same function, 5 times something minus 4, but that something is the other function, right? And so it asked you to write it in descending order, so you'd want to expand this. So I get 10 minus 5x squared minus 4. To put it in descending order, I can combine my 10 and negative 4, so I have a negative 5x squared, but then 10 minus 4 is plus 6, and that's my solution. Okay. The other question in this one is g composed of f at 2, right? Oops, I don't want to erase that. Get rid of this for a second here. So there's two ways I can look at this. There's g composed of f. I have g composed of f at 2. I can take g of f of 2. I can think of it that way. And it doesn't matter if I plug f of x into g and then plug 2 in for x, or if I plug 2 into f and then plug that into g, right? I'll do it both ways, right? So I can figure out g composed of f of x first, which is to say g of f of x, which is to take f of x and plug it in for g, so that is 2 minus, and instead of x, now I have 5x minus 4 squared, right? And then I can plug in 2 into this, right? If I wanted to, I could expand this. It gets kind of big and ugly. It turns into a trinomial with a 25x squared. Maybe I don't want to do that. I can, it's perfectly fine. But I can also look at this and say my g composed of f at 2 can be g evaluated at f evaluated at 2. And I can say, well, I'm going to plug the 2 into f first. Plugging a 2 into f gives me 2 times 5, which is 10, minus 4 is 6, which is to say I'm simply evaluating g at 6. Because f of 2 is 6. So plugging 6 in, I get 6 squared. Let me write this out. 2 minus 6 squared, which is 2 minus 36, which is negative 34. Either way, it doesn't matter, you can do it both ways. Figure out g of f of x first and then plug in 2, or you can plug in 2 into f and then plug that into g. Right? One's just working left to right, the other one's working right to left. Alright, hopefully that was helpful. I think that was all that was asked. That's 25. 25 was the last one asked, so I will see you guys for the next video. Take care.